Hello. If this isn't giving you flashbacks to online learning, I don't know what is. It's like me to, have my stylus not work right now. So that's perfect. So I'm going to try my best to do this review using my finger as a pen. So I apologize for any messy writing that might occur, but I think we'll be able to make it work. We're going to go over this quiz. Remember, you do have your test tomorrow. It includes Unit 5, so that's our polynomials quiz that we already returned and went over. Make sure you do study a little bit for that as well. You did pretty good on this Radicals/Rationals quiz. If you have any questions, please feel free to shoot me an email. I'll try my best to answer. If you can send a picture even of your work and be like, hey, I'm doing this and it's not working, and I can try to help out from home. All right, let's get into this. So, question 1. Use the following to answer the next question. Number 1. The graph of f of x equals root x has been transformed to produce the graph y equals a root b x minus h shown above. The correct values of a, b, and h are. So it's key to know that we started with just our basic root x. That function looks like this. It starts at 0, 0. It goes up to 1, 1, and then it goes over. Sorry. The scale here is going up by 2, so it would go like this. Through 1, 1, and then off like that. Oh yeah, look at those drawings. That's beautiful. That graph has been transformed to be the graph that we see. So, things that we notice. First thing you should notice is that is flipped and it is pointing the opposite direction. That means my A value is going, or sorry, not my A value. My B value is going to be negative. The reason I know that is because I've had a horizontal reflection. Right? I was pointing off to the right, I reflected, now I'm pointing off to the left. So I'm looking for a negative B value. Looking at my answers, that kind of gets rid of those two. Next thing I notice is that my A value must be positive because it's still going upwards. It never reflected down into the other quadrants, into quadrants 3 and 4. It's still going up. So that eliminates any of my negative A values. So right off the bat, I've already kind of got it down to the fact that the answer must be C. Talking about the H value, so my H value would be translating left or right. If you look at this, my starting point should have been at 0, 0, even after a reflection, so it's 0, 0, and then that thing moved over here to 2, 0. That's 2 units to the right. That means my H value must have been 2. So number 1, the answer is C. All right. Numeric response number 1. The coordinates of the invariant point when the function f of x equals root x plus 3 is reflected in the y-axis and can be written in the form a, b. Place the value of a, then b in the numeric response box. I didn't give you numeric response boxes, so I was just looking to see if you could get that point a, b. Reading the question again. The coordinates of the invariant point. So that means a point that does not change. It won't move. When the function, here's my function, is reflected in the y-axis. Okay, I'm talking about invariant points when I'm reflected over the y-axis. My invariant point when I reflect over the y-axis will be my y-intercept. If you think about it, if I'm reflecting over the y-axis and I'm already on the y-axis, that point's not going to reflect to anywhere. So all you had to do for this question was find the y-intercept of that original graph, f of x equals root x plus 3. To find y-intercepts, you set x equals 0. That says x equals 0. So I would have y equals root 0 plus 3. That's going to be y equals 3. My point is 0, 3. when I reflect over the y-axis, that point will be invariant. It will not move. Awesome. That first page, you guys pretty much crushed. Second page was a little bit more challenging. So looking at this, which of the following points on the graph y equals f of x could not exist on the graph y equals root f of x? So the difference here, they had f of x, it became root f of x. You're looking for what would not exist. Things that don't exist when you square root them is if you square root a negative value. In this case, when we're square rooting things, that means you can't square root a negative y value. Looking at all of our answers, there's only one answer there that has a negative y. That point could not exist when I square root f of x because you can't square root negatives. So the answer is B. Remember, when we're square rooting functions, you're square rooting their y values. That's how you find out where the point goes to. Cool. Number 3. A continuous function is written as shown. F of x equals negative a root 2x minus h plus 7. Where a is greater than 0 and h is greater than 0. That's telling you that both those values are positive. A true statement about f of x is the range of f of x is 7, to infinity. The domain is h, to infinity. Compared to y equals fx, it's been reflected in the y-axis. Compared to y equals fx, it's been horizontally stretched by a factor of 2 about the y-axis. Okay. Let's talk about what we got. So, we're talking about a root function, a radical function. A normal radical function looks like that. Starts at 0, 0. It goes up and to the right and makes that nice little curve. Our function has been moved quite a bit. I have, first off, negative a. The value of a is going to be positive, but there's a negative in front of it. That means that my thing is going to be reflected vertically. So it'll now look like this. Next thing I notice is that it's going to be stretched by a factor of 1/2. Visually, that's going to be hard to really tell what happens. Basically, it's just going to get squished in a little bit, but the shape will look the exact same as that blue one still. Next thing I notice after that, I have minus h. That h value will be positive. That means my function is going to translate to the right. And then I have plus 7, which tells me it's going to then translate vertically up 7. So my function should go to the right, h, and up 7. It should look something like this. Let's do it over here. Right now it looks like this. That point that it's at will be h to the right and then 7 up. That's what my graph will end up looking like. Describing that, it says the range will be from 7 to infinity. That is not true. That's saying it starts at 7 and goes up to infinity. My green graph is definitely not going up anymore. It's going down. So that range is incorrect. The domain is h to infinity. That is true. So if you look at my green graph, it went h to the right. So that means my furthest left point will be h, and it does go to the right to infinity. So the answer would be B. The domain is h to infinity. Question C, compared to root x, y equals f of x has been reflected in the y-axis. That's incorrect. It was reflected in the x-axis. Right, I flipped over the x-axis, not the y-axis. And D, compared to it, it's been horizontally stretched by a factor of 2 about the y-axis. That's not true. It was stretched by a factor of 1/2, not 2. That's not D. Cool. Number 4. The function f of x equals root x plus 3 is stretched about the x-axis by a factor of 2 and reflected about the y-axis. The graph of the transform function will have the same domain and range, the same range but a different domain, same domain, different range, different domain, different range. Okay. If we think about what happens. The function root x plus 3 would look like this. It's starting at 3. Right? It's our basic function, but it's 3 up. If I stretched it about the x-axis by a factor of 2, the domain and range aren't going to change. It's going to get stretched upwards. I lied. This is going to change things. Because I'm not talking about root x. I'm talking about root x plus 3. So if I stretched that red graph by a factor of 2, that means my starting point was at 3. It's now going to be at 6. Right? If we imagine this one started at 3, it's now going to go up to 6. And then it would go up from there. And it is then reflected about the y-axis. If it's reflected about the y-axis, it means it's now pointing this way. So if I look at that green graph compared to that red graph where I started, my domain has for sure changed. It's no longer going to positive infinity. It's now going to negative infinity. And my range has also changed because the lowest value I could get is now 6 instead of 3. That means I have a different domain and a different range. It's D. The key there is realizing that my first function was root x plus 3. So it was off of my regular function at 0, 0. Number 5. A continuous function y equals fx has zeros, -5, -1, and 6. Remember, zeros means x-intercepts. So when you read that, zeros means x-intercepts. The domain of y equals root fx is the set of real numbers such that x is greater than 6, or x is greater than -5 and less than -1. The value that is negative is f at -3, f at 1, f at -1, f at 9. Okay, so if we're talking about our original function, f of x, the only thing we know about is the x-intercepts. They're at -5, -1, and 6. They then tell you the domain, so possible x values for when you square root f of x. They say that it could be anything bigger than 6, so anything bigger than 6, or in between -5 and -1. So in between here and here. Those purple spots are things that could exist if you square rooted the original function. That means the original function had to be positive in between those points. Right? So the original function was positive here and positive here. Where the function doesn't exist means that the original function was negative. So anywhere in here, the original function was negative. Anywhere over here, the original function must have been negative. They asked you the value that is negative. The answer would be f at 1. F at 1 must have been negative. The reason I know it's negative is because it doesn't exist when I root f of x. So if you think about f of -3 must have been positive because that's in here. F of -1 isn't negative because that's an x-intercept. They already told me that, right? F at 9 is somewhere over here. That means it was positive on the original function. F at 1 doesn't exist on the root function. Therefore, it must be negative in the original function. My dog is snoring next to me. I don't know if you guys can hear that. I swear it's not me snoring while I'm talking. All right, number 6. If function f is f of x, they give it to you, then at x equals 3, the following is true. Vertical asymptote, there's a hole, f of x equals 0, the graph of f has a hole at the point 3, 2. Okay. To know if something has a hole or not, you have to simplify this thing. So to simplify this, you're going to factor it. To factor the top of it, you could take out a GCF of 4x. That leaves you with x minus 3. In the denominator, I can do a difference of squares. That means it's x minus 3, x plus 3. And you'll notice that on the top and bottom, you have an x minus 3. That means those things are going to cancel out. When you get that, when you get those values that cancel out like that, that's telling you that you're going to have a hole at x equal 3. We call that a point of discontinuity, right? It's a hole in the middle of your equation. Had those things not canceled out, I would have had an asymptote at x equals 3, because then I would have been dividing by 0. In this case, I'm dividing by 0 when x equals 3, but because it canceled out, it doesn't create an asymptote, it just creates a hole. To figure out the location of that hole, you then take your simplified equation, which is 4x over x plus 3, and you test what happens at x equals 3. So you put 3 in there, you get y equals 4 times 3 over 3 plus 3. 4 times 3 is 12, divided by 6, that is 2. That means your hole is at 3, 2. The answer is D. Cool. Cool. You ever watch Community? Nobody watched Community. That's okay. If you watch Community, you know what I'm talking about. Looking at number 7. Which of the following below has a hole at 1, 4? So this is pretty similar to the question above. A hole means you have to have the same binomial on the top and the bottom that's canceling out that would have caused you to divide by 0. So for instance, A would have a hole at 1 for sure, because there's an x minus 1, x minus 1. Okay, so that's possible it has a hole. B would not have a hole at x equals 1 because there's no x minus 1 canceling top and bottom. C would not have a hole because there's no binomial on the top canceling with any binomial on the bottom. D might have a hole at 1 because x minus 1 cancels out with x minus 1. To figure out where the hole is, you test what happens when x equals 1. You could test both of these. Only one of them will give you a y value of 4. The one that gives you a y value of 4 is D. So if you tried it, it'd be 11 times 1 plus 1 over 1 plus 2. On the top, that's 12. On the bottom, that's 3. 12 divided by 3 is 4. That means my hole is at 1, 4 for function D. Holes come from binomials canceling top and bottom, and then testing what would make that thing 0 before it had canceled, before you had canceled it out. You obviously test after you've canceled it out, otherwise you'd be divided by 0, and it wouldn't be possible. Okay, we are rolling right along. Numeric response number 2. Function is defined by f of x equals x squared minus 9, x squared minus 5x plus 6. On the graph of x, where there is a vertical asymptote and the point of discontinuity. Point of discontinuity is the mature way of saying that there's a hole. Okay, so we have a vertical asymptote and we have a hole. The vertical asymptote is at x equals a. Place the value of a in the first box. The point of discontinuity is at b, C. Place the value of b in the second box, c in the third box. Okay, to figure out where our asymptotes and holes are, we have to simplify this thing. Before we simplify it, we factor it. On the top, that is a difference of squares. That's x minus 3, x plus 3. In the denominator, that is a diamond method. Things that multiply to be 6 and add to be negative 3 would be x minus 3, x minus 2. Some people had x minus 6 and x plus 1. That would multiply to be negative 6. Right? So I had to have two negatives to multiply to be positive 6. Looking at this, I will have a hole at 3. Hole. That's not how you spell hole. Hole at x equals 3. The vertical asymptote will be at 2. Because that one didn't cancel out. To figure out exactly where that hole is, I need to go to my function and test the x value. So in this case, I'm testing x equals 3, so it'll be 3 plus 3 over 3 minus 2. That means that my hole will be at 6 over 1, which is just 6. My hole is at 3, 6. The answer was 2, 3, 6. Vertical asymptote at 2, hole is at 3, 6. All right, number 8. Which of the following best represents the rational function x over x squared minus 4x? Okay, to know which one of these would work best. You could graph it. I suspect some people just graphed in their calculator and figured it out. To do that without graphing in your calculator, I'm going to factor this thing. When I factor this thing, I can GCF an x out, leaving me with this. That denominator tells me that I will have a vertical asymptote at 4. Vertical asymptote at 4. Looking at my answers, they all have a vertical asymptote at 4. The next thing it tells me is that I have an x that would cancel with an x. That gives me a hole at x equals 0. Looking at my answers, there's no hole on A, there's no hole on C. B has a hole right there, D has a hole right there. Both of them are at x equals 0. To know which one is correct, I need to test that hole. So I go to my function, I have 1 over x minus 4. I change x to be 0, that's 1 over negative 4. That means my hole will be at 0, negative 4. That is B, not D. D is at positive 1 over 4. All right, heading into the written response. This is a perfect time to pause the video, smash that like button, hit the subscribe, look for that little tiny bell. Make sure you click that, get notifications so you are up to date on all the latest math videos. If you don't do that in the next 10 seconds, your crush will hate you for the rest of your life. Very deep. I'm sorry. Let's make it more positive. If you do that in the next 15 seconds, you will win $1 million at some point in the next year. Yeah. All right. Written response number 1. State the transformations and give the coordinates of the point x, y. I'm going to say the coordinate. I can't write it, not without a pencil. My hand will not work. But I will describe all of them. Starting with this negative 2. So that negative tells me that I have a vertical reflection about the x-axis. You do need to say vertical reflection, not vertical flip. It's a vertical reflection about the x-axis. So you have to say what you're reflecting over. The 2 tells me that I have a vertical stretch by a factor of 2 about the x-axis. So again, I'm saying what it is. It's a vertical stretch. I'm saying it's by a factor of 2. That's what I'm multiplying by. Factor means multiply. And it's about the x-axis, meaning I'm stretching away from the x-axis. Next one is this -6. The negative tells me that I'm doing a horizontal reflection about the y-axis. The 6 tells me that I'm doing a horizontal stretch by a factor of 1/6. So 1 over 6. Remember, horizontal reflections, you have to do the 1 over to figure out what it is. The inverse. Not the inverse, the reciprocal. Jeez Louise. So that was a horizontal reflection about the y-axis, and then a horizontal stretch by a factor of 1 over 6 about the y-axis. So I'm stretching away from the y-axis. And my last one, this x minus 2, that's a horizontal translation 2 units to the right. Perfect. The other thing that it asked you to do is describe where that point went. So that point would have gone to -1 over 6 times x, and then plus 2 to the right. The y value would have been -2 times y. That's where that point would have gone. Some people actually went and found points and then transformed them. That's not what they want. They want you just to do the general point x comma y. Perfect. Number 2. Oh gosh, I really wish I had a pen for this. Consider the graph of y equals fx. On the same grid, sketch the graph of root f of x. Okay. Sketching this. You're going to square root y values. Okay. We know that you can't square root negative numbers. So this whole part of the graph, like, there should be nothing down here. Because if you square rooted a negative number, it wouldn't exist. Therefore, anything that was negative can't exist. So nothing below the x-axis exists. The first thing you could square root is 0. That point has to exist right there. You need to start your graph at that moment. Next important point. A value I can square root is y equals 1. The square root of 1 is 1. This point has to exist. Perfect. The next point that I can... Sorry, let's connect those 2 dots because that's important. When you're in between 0 and 1, it is important that your radical function, that's my root function, goes over top of my original function. So it needs to look like this. It needs to clearly go over. I'm trying to do this with my finger. It's not easy. Yeah, like that. See how I'm above it? Perfect. Next point I can square root would be y equals 4. Square root of 4 is 2. If I look along the top, there's a 4 right here. I can square root that to down here to 2. Same thing right there. From there, I'm basically just playing connect the dots. So it's going to connect up, and then it's going to go straight across, like that. That is my radical function. Notice that it stops. I don't have arrows on the end. There's nothing in the negative realm. I went over my original function in between 0 and 1. Cool. Write the domain in interval notation. So domain is possible x values. The furthest left this thing goes is -2. The furthest right that it goes is +4. That's interval notation. Notice that I'm using square brackets because I can equal -2 and I can equal +4. My range in set builder notation. So I go range, curly bracket, y values, such that. I then state my lowest y value, and I'm always going smallest to biggest when I'm doing set builder notation. The lowest y value I have is 0. Everything else will be bigger than that or equal to that. So I use that symbol and put a y. That is saying y will be bigger than or equal to 0. I then put the highest y value I could have. The highest y value I could have is positive 2. I use that symbol because that's saying that y will be less than 2. Right? It'll be below that point. I then go comma, and I say y could be any number as long as it follows that rule in between 0 and 2. That is set builder notation. All right, number 3. Determine the solutions to the equation root x minus 1 equals x minus 3 algebraically. I had a few people do some guessing and checking and called it inspecting. That's not inspecting. It's guessing and checking. Algebraically, you have to show me, break down, work. It has to also get every possible solution. Okay, to do this, we got to get rid of that square root sign. Get rid of that square root sign, you square both sides. When squaring both sides, remember that is x minus 3 in brackets. So I now have x minus 1 equals x minus 3 in brackets squared. It's not x squared minus 3 squared. Right? It's x minus 3 squared, which then has to be expanded using x minus 3 times x minus 3. Right? Like that's what that means. When you do that expansion, you get x minus 1 equals x squared minus 6x plus 9. If you did that, I think I gave you 1 mark, maybe only half a mark at this point. I then needed you to recognize that this was a quadratic function. To solve quadratic functions, you have to equal 0. That means I need to subtract my x and add my 1. So I subtract x, I add 1, and I now have 0 equals x squared minus 7x plus 10. To solve that, I needed to factor it. You could have done the quad formula. If you do the quad formula, make sure you get both positive and negative answers from the root sign. I would prefer you factor it. That would be x minus 5, x minus 2. So that's values that multiply to be positive 10 and add to be negative 7. That gives me my two solutions, x equals 5 and x equals 2. If you did all that, you got 1.5 out of 2 marks. The reason you did not get 2 out of 2 is because one of these solutions doesn't work. The solution that doesn't work is x equals 2. If you actually test these answers, this one becomes root 5 minus 1 equals 5 minus 3. 5 minus 1 is 4, square root of 4 is 2. 5 minus 3 is 2. That one works. X equals 5 is one answer. If I try x equals 2, I get the square root of 2 minus 1 equals 2 minus 3. 2 minus 1 is 1. The square root of 1 is 1. 2 minus 3 is negative 1. That does not work. So I cross out that answer of x equals 2. There were a couple people that said the square root of 1 is positive and negative 1. You're not incorrect. The problem is they said that this was the positive root. Right? Like they never put that it was the positive or negative root. So you can't assume that they meant positive and negative root sign. We only put that positive and negative if we create the root sign. If they put the root sign in the question, then we just know they're only talking about the positive root. So unfortunately, x equals 2 does not work. You had to show that you did not like that answer to get the full mark. All right, Last page. Graph the function y equals 2 over x plus 3 minus 4. In this format, these values are telling you where your asymptotes are, because these are horizontal and vertical translations. The first one, x plus 3, is telling you where your vertical asymptote is. It's telling you your vertical asymptote is at -3 because it went 3 to the left. The minus 4 is telling you where your horizontal asymptote is. It's telling you it's at -4 because the original function went down 4. So I was looking for you to draw those asymptotes right here. And you would draw them with dotted lines, right? That was bad. I'm not going to be able to draw a nice dotted line with my finger. Oh, that's pretty good. Okay, so I'm looking for those vertical and horizontal asymptotes. The next thing I'm looking for is that you have a stretch of 2. Whoa. My carumbas. You have a stretch of 2. That means that you should have had an original point that was 1 over and 1 up, right there, and 1 right there. Had this thing not been stretched, that's what your graph would have looked like. But those points were vertically stretched by a factor of 2, meaning that it's not going to be 1 up, it's now going to be 2 up from the center of those asymptotes crossing. That and that. You then would draw a nice looking function like this with arrows on it. You do have to have arrows. Make sure you draw it as close to your asymptotes as possible without going over. Perfect. Part B. The transformations, the 2 up here is a vertical stretch. It's not a horizontal stretch. If it was a horizontal stretch, it would have been right on the value of x. It would have been in here, but it's not. It's on top of the fraction. That means it's a vertical stretch by a factor of 2 about the x-axis. You're stretching away from the x-axis. This plus 3 is a horizontal translation, 3 units left. I don't say that it's a horizontal translation by a factor of 3. Factor means multiply, and translations are not multiplying, they're adding or subtracting. So it's a horizontal translation, 3 units left. And then the minus 4 is a vertical translation, 4 units down. Again, it's 4 units, not by a factor, and I don't say 4 units down from the x-axis or something like that. I just say it's 4 units down, because every point was going to move 4 units down. Perfect. Number 5. Last one. Looking at this, algebraically manipulate it so that it's in our transformation form. To do that, you have to somehow take that top function and GCF the 4 out. All right, you got to get rid of that 4. And then you need to get a binomial that's the same as the one on the bottom. So our goal is to take that function, GCF the 4, and somehow have x minus 3. Well, the only way I could GCF a 4 out of there is if this had been 4x minus 12. Right? Like, that's the only way I could GCF a 4 and have x minus 3. Looking at the original function, I don't have a negative 12. I have a plus 5. So I need to turn that plus 5 into a negative 12. I'm going to do that by subtracting 17 to the original function. To counteract the fact that I'm subtracting 17 from the original numerator, I'm also going to add 17 to the original numerator. So it now looks like this. Y equals 4x minus 4x, I don't like the way I'm writing this. That plus minus 17, I'm doing to the original equation. I'm taking that plus 5, I'm going to subtract 17, so it becomes minus 12, and I'm going to add 17 to kind of balance out the fact that I subtracted 17. So it now looks like this. 4x minus 3, so that's after I GCF the 4 out, and then I would still have the plus 17. The denominator is just x minus 3. It's not changing. From that point, I can then split this into two fractions. The first one is with that factor of 4x minus 3. The second one is just the plus 17 over x minus 3. The reason I do that is because that first fraction can now simplify to be y equals 4. The second fraction is 17 over x minus 3. If I rearrange this, I now have my transformation form. There's my a value, x minus 3, that's my b value, plus my c value, which is just 4. Boom, bada boom, bada bing. I think that's the right thing to say. I don't know, it's a pizza commercial. That is all I have for you guys today on that quiz. Here's hoping that this video turned out. If you have any questions, remember, shoot me an email. I will try my best to be there and support you. Thank you. How do I stop a video? Nobody knows. How long will this video go until I figure it out? Oh, there it is. Bye.